Assalamu alaikum sir, my name is MD Tasnimul Khairishan and I'm gonna present my final OBE assignment now. In this assignment we had to design a parking system where we can count the incoming and outgoing cars. Also we can select the number of cars that can store in our garage. Now let's get deep into this system.
According to my idea, the maximum number of cars we can store in the garage is 6 cars. Now, this is the block diagram of the whole system. A keypad is used to input the maximum number of cars we can store in the garage. An encoder is connected to the keypad to convert this decimal value to a binary value. A up-down counter is used to keep the track of incoming and outgoing cars, which tells us how many cars are still available in our garage. Now the value from counter and keypad are connected to a comparator, which makes a comparison between them. If the counter value and the keypad value are equal, or the keypad value or the counter value is greater than the keypad value, it's gonna show full on the display. And if the keypad value is greater than the counter's value, it's gonna show space available on the display.
This is the flow diagram or flow chart of the system. If a car enters, it puts a pulse into the up down counter, which makes the counter up count. If a car exits, then it makes a down count to the counter. Now the value of the counter is passed to the comparator, which compares between the inputted value, which was 6. So if it is equal or greater than 6, then the display shows full. If it's not equal or not greater than 6, then it makes another comparison where it where it shows if it's less than 6. If it's true, then the display shows space available. If false, then it shows the garage is full. Let's have a look at the state table of the up down counter. We have used 3-bit up down counter because we wanted to hold 6 cards. Now when the counter starts, it starts from its initial value, which is 0. So the present state becomes 000. Now the next stage for up count becomes 1, which is 001, and for down count becomes 7, which is 111. Now this 1 becomes present state, so the present state is now 001, and the next state for up count is 2, which is 010, and down count is 0, which is 000. By following this, we have filled the whole table. Now we will use K-map to find all the possible expressions from this table. The row number of each present state states the number of cells we want to fill. So first of all, it's 000, so it determines the cell number 0 for both J and K. As we are working with the K naught value at the Q naught value, so we have put it J naught and K naught. Now we will look for the change to the next state and present state, and according to that we will search in the JK flip-flop transition table and put the value in J and K maps. By doing this, we will have 6 K maps and 6 expressions. As we have taken 3 bit of up down counter, so there will be 3 flip-flops. All the flip-flops clock is connected in common because this is in synchronous counter, and the expressions we got, we will use them to connect the pins using some gates. This will create a up down counter which we want. Now in question 2, we have to design the both 555 timers which were used to create different state for the displays. According to my ID, P is 28 and D is 72% or 0.72, and the frequency is 6 Hz. So total time duration is equal to 0.17 seconds. Now using the TH, TL and D formulas, we can derive the D formula, which is R1 plus R2 divided by R1 plus 2R2 into 100%. So we can put the value of the D which we got from our ID here, and we can get a relationship between R1 and R2. Now let's set the value of the capacitor is 50 microfarad. This will help us to get a common resistor value. So the time period is 0.69 C R1 plus R2. Here we will put the values of T, C and the relation we got from the last page. From here we can get the value of R1, which is 2.13 kilo ohms, which is we can say that it's 2 kilo ohms, and R2 is 1.3 kilo ohms, which we can say is 1 kilo ohm approximately. Now we can calculate the value of TH and TL by putting these values. Now using the value of the resistor and the capacitor, we will design our monostable mode 555 timer and astable mode 555 timer. We created monostable mode 555 timer for showing full because it stays static, and the astable 555 timer for blinking to show the space available. In question number 3, we have to prepare an FSM for this system. So from the previous question we got the TH and TL value, which was much greater than 4 milliseconds. So we will assume TH is equal to 4 and TL is equal to 4 milliseconds according to the question. Now we can see there is a basic diagram of the FSM architecture. Here we used 3 because we have used 3 bit of the system. This FSM is an control dominated FSM because the output is not dependent on any internal calculations or any situations. So we can say that it's control dominated FSM. Now we can see a basic diagram of control dominated FSM. Now we can see the state diagram of the FSM, where there are two pins, which is go and preset. When we are pressing go, the loop starts from 0 to 7 and it keeps circling from 1 to 7 around and again. When the reset is pressed or the reset pin gets power, only then it gets to the 0 and stucks there. Now we can see the state table of the FSM. Here, when reset is 1, we don't care about the present state and input because the output will always be 0. Now when reset is 0, then the values will differ. So when present state is 0 0 and input is 0, the next state is 0 0 0 and output is 1 0. So when present state is 0 0 and input is 1, then the next states become 1, which is 0 0 1. According this, the whole system keeps looping around. So in the output we can see there are 4 ones at A and 4 ones at B, because we determined that TH is equal to A, which was 4 milliseconds, and TL is equal to B, which was also 4 milliseconds. From this state table we can find the expressions of the outputs and the states. Now for the HDL code of the FSM system, first we declared a module named TLC binary, and that we have declared input wires CLK, RST and go, and the output wires are A and B. Now we defined a present state with wire of 3 bit and a next state. Output, the output logic we have assigned is A and B. So the A is the expression we got before and written it in using the special symbols. All same goes for the B, which we have assigned with present state to. Sorry for the writing mistake here. I have written that assigned A, but it will be assigned B. After that, we ended the module. Now for the fourth question, we will see some limitations of this system and the modifications. The first limitations is it can count up to 8 cards maximum, because we have used 3 bits of counters here. The second limitations is during the state change, IC's output and gates will flicker. And the third is there can be miscounts, glitches and overlapping problems. Now let's talk about the modifications. To increase the capacity, we can use a 8-bit or 16-bit counters. It will increase the number of cards we can store in the garage. The next modification is we can use microprocessors instead of the counters or ICs. This will highly increase the efficiency of the whole system. The next modification is we can use microcontroller to count the cards and keep the track of exiting and entering. This will solve the problem of miscalculation, overlapping or any type of glitches. And the fourth modifications we can do is we can use a buffer register before the displays to stabilize the display output, because in low frequencies the displays can flicker, so it will be much harder to see the text there. Thank you, sir. This was my whole presentations, and sorry for the mistakes I've done here. Thank you, sir.